And welcome to our video on the addition rule for probability. Now, a quick reminder from our previous videos. Before I fill this in, you might like to have a go at shading in A intercept B in this diagram and A union B in this diagram. Okay, hopefully you've had a go at that. A intercept B is the part in the middle there, in between the two sets, and A union B is everything in A, which includes this bit, plus everything in B, which includes the middle bit as well. Hopefully you got your shadings correct. I'd like to look at a new Venn diagram I've put together here. We have two sets, A and B, and some numbers in each one. And these are the different possible outcomes. They're not the probabilities, and they're not how many there are in each set. So if we look at the number of elements in A union B, so that's this whole thing, everything in A, everything in B, and everything in the middle. We have 1, 2, 3, 4, 5, 6. So the number in A union B is 6. And some people like to say the number in A union B is the same as adding up everything in A plus adding up everything, the number of elements in A plus the number of elements in B. So in A we've got everything inside this circle, which is 1, 2, 3 elements. In B we've got everything inside this circle, which is 1, 2, 3, 4 elements. We find out 3 plus 4 doesn't equal 6. So what we need to do here, hopefully you've twigged and realised the mistake I've made here. We've counted this 4 twice. So we need to take away the number in A intercept B. There's 1 in the intersection, which is this bit here in the middle. 3 plus 4 is 7, take away 1 and we get our 6. So this is the rule you need to use. If you're trying to find the number in A union B, it needs to be the number in A plus the number in B minus the number in A intercept B. If we take this rule and we assume that every one of these outcomes is equally likely, then we could work out the probability of A union B is going to be the number of elements in A over the total number of elements, which is the number in the universal set, plus the number in B over the total number, minus the number in A intercept B over the total number. And we can rearrange this to write it as, because the number in A over the total number is just the probability of A happening, plus the probability of B minus the probability of A intercept B. That is equal to the probability of A union B, and that is something I would put in my summary book. And it's called the addition rule. Even though we found this rule by assuming every outcome is equally likely, that's how we came to this rule and derived it. Now that we've got it, it also applies in situations where the outcomes are not equally likely. So you just need to keep that in mind. It can be used in any situation. Example 1. If one card is chosen at random from a full deck, what is the chance that it is a king or a spade? Example 1. If one card is chosen at random from a full deck of cards, what's the probability that it's a king or a spade. Sorry, I was just distracted by Ted, and I think I read that question out twice. First step is to define your sets. The second step is to write the known probabilities. Third step is to write equations as a probability statement. Fourth step is to write the addition rule that we've just learnt up here. And the final step is to write the solution. Let's have a go at working through this problem. Okay, first step, define our sets. Let K equal selecting a king. Now it doesn't say in this problem what you need to use. You could use A for a king and B for a spade, or K for a king and S for a spade. Completely up to you, but you must define it properly. I'm going to use S for selecting a spade. Second step is to write the known probabilities. I'm going to start with writing out the outcomes of each set. So choosing a king, you could get a king of spades, a king of clubs, king of hearts, or a king of diamonds. Those are our only options. If you're selecting a spade, you could get a 2 of spades, 3 of spades, all the way up to a king of spades and an ace of spades. You might be okay with just keeping this in your head, which is fine, but sometimes you might get a problem that is a bit more complicated, and it can be useful to write out all the different sets there. So we can now write out the probabilities. Probability of selecting a king is how many kings are there in a pack? 4 out of 52. Probability of a spade is how many spades in a pack? 13 out of 52. And you could simplify this, but I'm going to leave it as over 52, and you'll see why in the next step. We need, for our addition rule, we also need probability A intercept B. A intercept B is going to be where these two sets intersect. So we've got king of spades in both of them. So it's where you get a king and a spade. And there's only going to be one card that's got a king and a spade on it, the king of spades. So that's in our set there. The probability of A... Oh, why have I put A intercept B? This should be K intercept S. And this should be the probability of K intercept S, which is 1 out of 52. Next step is to write our addition rule. Probability of K plus probability of S minus probability of K intercept S equals probability of K, 4 out of 52. Probability of S, 13 out of 52. Minus probability of K intercept S, 1 out of 52. And this is why I've left them all out of 52, because it's a ton easier to go 4 plus 13 minus 1, which is 16, and the whole thing is over 52. The last thing I would like to just make sure I mention is mutually exclusive events. And they are when there's no intersection between your two sets. So they don't cross over at all. They're completely separate. This might be A and this might be B. No intersection. And when that happens, probability of A intersect B is equal to 0. So the probability of A union B is just probability of A plus probability of B. Only when they're mutually exclusive, because using our addition rule, it'd be A plus B minus A intercept B, but there is no intersection, so this is minus 0 in the end. So you can just use this formula here if they are mutually exclusive, which means they're not, you can't have both things occur. You can only have one thing occur at a time. Thanks for watching the video.